Okay, so for this next program, I'm going to print out the larger of 2 or 3 numbers. So let me type up. In this case, I have A, which is some number, B, which is some other number, and C, which is another number. And I'm going to try to print out which one is the largest. So larger, C. Okay, so I can do this with some basic if statements. So if A is larger than B and A is larger than C, then A must be the largest, right? So print out A. Otherwise, we know that A isn't the largest already because from this. So otherwise, if B is larger than C, then we have the largest as B. Otherwise, we have the largest is C. So in this case, it's printing out the largest, which was C there. Let's print out here A equals this, B equals this, and C equals this. And put an A, B, and C there, so we can see these variables. And then I will use the rand function. So srand. I'll randomly seed srand with the current time, and then get random numbers between 0 and 99. So yeah, so these random numbers between 0 and 99, there's 82, 15, and C, and then just printing out the larger. If you want to go a step further and print out the largest and the second largest, you can say if A is greater than B and A is greater than C, and then if B is greater than C, then you're printing out B is second largest. Let's just use quotes. Otherwise, in this case, then C is second largest, right? So then you can do this for all the cases. So else if B is greater than C, then in this case B is largest. Otherwise, if A is bigger than C, then A is second largest. Otherwise, C is going to be second largest again. Then for the final case, we know that C is the largest. So we already know C is the largest. So if A is greater than B, then A is the second largest. Otherwise, it's going to be B. So in this case, the largest is C, and the second largest is A. So C is the largest, A is the second largest, like that. Okay. This one, convert a number from binary to int, and convert from int to binary. So let's create a new file. equal binary to int.c. Okay. And I remember that when we did number 1, I think it was. No, it wasn't. It was number to word. We used several of these functions, such as extracting a number, and we also computing the number of digits. So let's use some of those. So what was this one? This was number to word. Binary to int. And then reload this. Okay. So if we're given the binary number, so say 9, like this, let's first compute the number of digits. Okay, so the number of digits can be computed in this variable, and then basically just like the base 10 system, where the first one would be the column, the ones, and then the tens, and then the hundreds, and then the thousands. In binary, we're going to have the first column is the ones, then the twos, then the fours, then the eights, then the ones, then twos, then fours, then eights. Then 16s and so on, but we'll just assume that the number is something like this long. So in the ones column, in this case, we have a 1. So 1, that's 1 times 1. In this column, the twos, so let's just put this here, 1, 2, 4, 8, and 16. In the twos column, we have a 0, so it's 0 times 2. And then in the fours column, we have a 0, so it's 0 times 4. Then in the eights column, we have a 1, so that's 1 times 8. Then we don't have any more, so that would just be 1 plus 0 plus 0 plus 8, which is 9. If we have the same here for 8, 9, 10, 11, 12, 13, 14, then we have 1 in the ones column, a 0 in the twos column, 1 in the fours column, and 1 in the eights column. So it would be 8 plus 4, which is 12, plus 1, which is 13. Sorry, my miscalculation, 13. So essentially we're going to be going up here through these digits, and then if it's a 1, then we add that number, otherwise we don't add anything. So let's have a for loop that is going up from 0 until we go to non-digits, plus, and then let's print out this I to make sure that we're going to the right thing. Binary to int. Okay, so let's print out this. We have a reference to log, and that's just because of my compiler. Okay, there we go. So we're going up and we're going to do the 0, 1, 2, and 3, these columns. So let me get the digit. Digit equals n divided by int 10 to the power of I, then mod 10. And instead of printing out I, let's print out this digit. So there's our number. So let's have another variable that is j, and at the start j is going to equal 1 because we're going to be in the ones. Then we'll need to multiply j by 2 each time. So j equals j times 2. Let's print out the digit and print out j as well. Oops, j. Okay, so the ones column, we're adding 1 times 1. Then the 2's column, we're going to add 0 times 2. Then this column, and the four's column, it's going to be 1 times 4, 1 times 4, then 1 times 8 here. So let's have an output. Output equals 0. Along the way output, we're going to add d times int d times j. So yes, since we have this here, we can replace this with j as well, because oh no, we can't replace that with j, sorry. Yes, so that's indexing by the decimal, and then this will be yes, adding in the correct decimal output. Yes, so at the end, let's print out this output like that. So the output here is 13. So let's get rid of this, and then we have our working example. Then let's put in the number 15 like this. And then that gives me 15. Let's put in number 7. 17. Oh, yes. 4, 5, 6, 7. That should be 7. Let's go back and print out these. Okay. That's strange. Okay, so now it's printing out 7. Okay. Just because I had the 0 there. Is it? Yes, okay. Okay, that's interesting. But anyway, now we have the right answer. So then we can put something like this in binary is in decimal. And this one. So 111 in binary is 7 in decimal. Okay. So there's that one. And then why don't we have converting back maybe? One of the ways that you can convert backwards, I think you may, actually I can do it without that actually. So one of the ways we can convert backwards, so let's put the output backwards through this, okay? We can divide by 2 every time and output the remainder. And then that should give us, that's the general algorithm to compute from decimal to binary. And it should give us the output backwards. So let me put this as 6 like this. So 110 in binary is 6 in decimal. And then let's put N2 as the output. And then say while N2 is greater than 0. We're going to print out N2 mod 2, and then we're going to set N2 divided by 2. So that is giving us 0, 1, 1 instead of 1, 1, 0. So we actually need this number to be backwards. So what we can do is we can multiply it by multiply it by 10 in the correct column to shift it outwards. So let's set out2 to 0, and I will print out output. Yes, this in decimal is this in binary. So the output was in decimal, and then out2 is going to be in binary. So write this so we can test. Let's put some new line there. So 6 in decimal is going to be this answer. So here, let's put out2, add that n2 of 2 to that. So that's gonna give us put the correct 1 or 0 into the ones column, but then after we do that, we want to multiply that by 10, so that shifts it along one each time. So yeah, 6 in decimal is 110 in binary. Let me get rid of this print and then test it with another. So 9. 1001 is in binary is 9. Well, in binary is 9 in decimal. And 9 in decimal is 1001, and then we've got the trailing 0 there. So in this case, let's at the end of this go out to divide equal 10. So we get rid of that at the end. And then we've got should have our working 1. So then you should be able to put in some random binary number, and that's 174, and then 174 is this. No, that should be right. Okay, so 0, 1, 1, 1. 0, 1, 0, 1. So we're getting the right output here, but it's not correct here. Okay, so that should be right. Out to divide equal n, divide equal 10. So let's test this by printing out out to here. So after adding the 0, it's this. After adding the 1, it's this. After adding another one, it's this. After adding this one, it's this. After adding this 0, it's this. And then this one is this. And then this 0, it's this. One, 0, 1. 1, 1, 1, 0. So this, I see. And it's putting it in the opposite columns. So 1, 0, 1, 0, 1, 1, 1, and then 0. Okay, yeah, so it's putting in the opposite columns. So in this case, we need to reverse this number as well. So in order to reverse the number, we can compute how many digits there are and then go backwards and reverse it. But let's try to start with this index value, which at the start is going to be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Like this. And then multiply this by index, and then at each step index we're going to divide equal 10, like that. And then check that. So output times equal index. This times index, and then we're going to reduce index each time. So then and still backwards. Index. Okay, so this looks like it's going right. So 1 0 1 0 1 1 1 0. That looks like it's outputting correctly now. So in this case, yeah, I'm multiplying it directly by that index, and then I'm multiplying index each time. Yeah, so it was right the first time. Yes, so this one I'm putting in the direct column straight away, but the other one I was shifting it up by 10 each time. But it doesn't matter, so we seem to have got the right answer. So let me go through that. 1 0 1 0 1 1 1 0. So let's check with other numbers such as 5. 5 is 1 0 1. Yeah, let's check with 7. Yep, so then we have a working solution that converts 2 from binary to decimal, and then from decimal to binary again. Yes. Okay, and I'll quickly do this one as well, palindrome, until my battery running out. So let's check this one. Is palindrome C, and this one is also going to be based on the number to word one. Is palindrome C. So this one we have some number which could be a palindrome. Let's make it into 1 6 2 2 1. In this case, basically the first thing that we want to do is compute the number of digits, so get the number of digits there, and then we're going to go from the start to the halfway point, and so here we'll convert the start one compare it with this, and then the second one will compare with this second one, then the third one will compare with this third one here, and so on until we reach the halfway point. So let's go from I equals 0, I 0, I is less than n num digits divide 2, I plus plus, and then let's print out all of those, all of the comparisons that we're going to make. So A is I, then we're going to set B as num digits minus 1 minus I. So comparing these two, A and B, no, don't do that. Okay, so here we have 0, 1, 2, 3, 4, 5, and 6. So we're comparing. So this is 6, 5, 4, 3, 2, 1, and 0. Those are the indices. We're comparing 0 and 6, and then 5 and 1 here, and then 2 on this side and 4 on this side. So if any of those indices aren't the same number, if these aren't the same number, then we know that it's not a palindrome. So let's get those two numbers out. So digit 1 is n divide 10 to the power of a mod 10, and then digit 2 is going to be that except for b. So then let's test this with d1 and d2. So first comparing the two ones, so this one, the first one and the last one, and then the two twos, so this 2 and this 2. And then let's change this to 8 here on these sides. I'll change that to 8, and I'll change this one to a 7 so it's not palindrome. And test, so 1s, the 2s, and then the 7 and 8, comparing them. So I can say if d1 is not equal to d2, then it is not a palindrome. So then we've got a similar problem to before. So if this is totally not a palindrome, then it's going to be printing out twice. So what we want to do is assume that it is. So is palindrome equal 1. If we find out at any point that it's not, then we can say is palindrome equals 0, so is false, and then break. And it wants to make me do semicolon there, so let's just do that. And then at the end we can go if is palindrome, then we'll say is palindrome, else we'll say is not palindrome. Okay, and actually let's put in that number so we can see. No, we don't need this. So that's not a palindrome. And let me just add these. If I put in a number that is a palindrome, 1, 2, 1, then that is a palindrome. So let me end it there because my battery is going to run out, and I'll try and make more videos at a different time. Thank you.